right. Hello, everyone, and welcome to IL SciComm. This is our third IL SciComm meeting, and we're very excited to have you all here. We are recording this, and it will be shared on our Science Teachers in Action website on the IL SciComm page. We started this group to celebrate all the great things that are happening across Illinois in our science classrooms with the hopes that we could also spread the joy and wonder of science. I am Janine Shepard. I am a math and science content specialist. And with me today, we have Crystal Clifton,
Hi.
who is a science content specialist, and Jesse Samine, also
Hello.
a science content specialist. And then Linda Vernon, our amazing boss in all of this excitement. So we are part of the Center for Educational Initiatives at Illinois State University, and we are partners with ISBE to support teachers in Illinois with implementation of the learning standards in all content areas. So we have ELA specialists, math specialists, social science specialists, and learning supports. We have a lot of us. There's 12 now. Also, I want to give a shout out to Caitlin Walker, our science principal consultant at ISBE. So she's here. She doesn't have audio today, but you'll see her chime in the chat window. So we're very happy to have her with us. A little housekeeping. If you have not already turned on your camera, please do so now, because we want to be able to have a fully authentic conversation. And while we are encouraging you to talk during the discussions, while one of our feature teachers is speaking, if you could keep yourself on mute so that the background noise doesn't become a distraction, that's very helpful. While you're in Zoom, if you click on gallery view, you can see everyone at one time. So otherwise, there's the speaker view, then you can only see the person who's the loudest, and that can be kind of distracting. Feel free to rename yourself so that the name on the screen reflects who you are. So if you want to do that, there's the 3 dots. You just hover your mouse over your picture and then click the 3 dots and you can rename yourself. We will have each of our invited guests talk, and then we will open up for discussion and questions. Depending on the size of our call, we're not doing breakouts today. Sorry, I'm reading a script and I did not read ahead. Disclaimer, any discussion or resource that is shared is not an endorsement by ISBE or ISU. We are only providing a platform for you to share your ideas and resources. I'm going to share a few things in the chat window. 3 resources. The first resource is our listserv. So if you did not hear about us through the listserv, please sign up for it now. That will be our main way to communicate. We're also available on social media, so you can see our Twitter account and our Facebook accounts there. And then I've also shared a link to our post survey, just so that you can keep that in mind as as we're going through on the reflection questions that we'll be asking. Hi, Melanie.
Hello.
There's a little bit of an echo, so I'm going to mute you.
Okay.
All right. That's another thing too. If at any point in time, like a fan in the background or there's an echo, I might mute you. Please don't be offended. I'm just doing it to try and maintain order. All right, now I'm gonna turn things over to Crystal and Jesse, and they're gonna lay some groundwork for our phenomena-driven discussion.
All right, thank you. So like Janine told us, today we thought it would be helpful for everybody to hear about how other teachers are using phenomenon and phenomena-based instruction in their classroom. We hope that it's just an opportunity for people to hear what other people in the state are doing around phenomenon-based instruction, to share some ideas and share some resources. We realize that people have kind of different experiences with phenomenon-based instruction and using phenomenon in classrooms. Some people, this might be their first introduction to the idea, and other people may be, just looking for other resources because they're using it already. So with that idea in mind, I'm going to screen share, I think. I've never done this before. I'm going to screen share a resource from Achieve and who else worked on this? The Next Gen Storylines. And now I can read it because I can see it, maybe. Nope. And STEM teaching tools called Using Phenomenon and NGSS Design Lessons and Units. So I highlighted a couple things. I think that this document is a great kind of starting point for people in being introduced to phenomenon-based instruction. So I highlighted a couple of things that I thought would be important for people who might just be getting started. So the first kind of thing that I highlighted here was just a definition of what phenomenon is. So natural phenomenon are observable events that occur in the universe and that we can use our science knowledge to explain or predict. The goal of building knowledge in science is to develop general ideas based on evidence that can help us explain and predict phenomenon. So that's just helpful for people who are going to hear about teachers using this so they know what it is. And then this section, I think, is really good in the introduction for phenomenon to teachers. So why are phenomena such a big deal? And I love this third bullet point. By centering...
Hold on. We can't see your screen.
Oh.
There you go.
Why not?
Second click.
Share screen.
Yay.
Can you see it now?
There you go. Yep.
Okay.
We got it.
And so this third bullet point says, by centering science education on phenomenon that students are motivated to learn and explain. Now I'm going to have to scroll down so I can see it. The focus of learning shifts from learning about a topic to figuring out why something happens. For example, instead of just learning about the topics of photosynthesis and mitosis, students are engaged in building evidence-based explanatory ideas to help them figure out how a tree grows. So that kind of sets the groundwork for us as teachers kind of share their experiences using phenomenon in their classrooms. How do I unshare now? Stop share. Got it.
Yay! All right. Perfect. Good job. Would you mind putting a link to that doc in the chat window when you have a chance?
Yep.
All right. So we are going to go now to Rebecca. Crystal, did you have anything to chime in?
No, I think that's a good introduction. And the goal here is to see how it's a kind of one lofty goal to get to that kind of teaching. And so the goal is for us to see how teachers are really doing that in the classroom and what effects it's having on their instruction. So.
Excellent. So now we're going to see some real teacher examples of what this looks like in our classrooms. So from our featured teachers today. So first we have Rebecca Shoemaker, so a sixth grade science teacher. I don't have at Hickory Creek Middle School.
Woo!
Sorry, little delay there.
That's okay.
So we are so glad to have you here today, and we're excited to see what you have to share with us.
Okay, so I kind of have a long history of the NGSS and trying to put these performance expectations and phenomena into practice. But it's been kind of like a long, not to say rough road, but it's taken a while to get to a point where, we've been feeling more comfortable with it. But as that's happening, I mean, it's just starting to really just like snowball and roll downhill. It's like getting easier and easier, and more and more people are getting on board, I guess, like on administration wise. I've been lucky and always had pretty supportive administration, so that's huge. But what I kind of wanted to do today was show everybody a little bit of like our process and how we're currently working to do some of these things. So like we're lucky our district was able to get us iQuest, sort of lucky, because it's a really good place to start. It was like, okay, these things are laid out for 6th, 7th, and 8th grade, and 6th graders are going to learn this, and 7th graders should do this, and 8th graders should do this. So that was kind of helpful. But we were finding, of course, that it wasn't hitting all the performance expectations that we wanted to. So like what we've started doing, and I don't know, can you see that? It's like a bit of an info, I guess we'll call it an infographic thing we used to terrorize the students, because we put this on my board, and this is what we taught them for our chemistry unit. We kind of like took the ideas from iQuest, realized some concepts that weren't quite being hit by all the activities in there for the performance expectations that we wanted to hit. And so we kind of, that's where we started supplementing. So like right away, we know we have to supplement stuff. But then, so the unit itself was, how can I smell things from a distance? And so that was like our phenomena of like this odor, and how can you smell stuff? And then we got into like, what does odor look like? You know, and all these other things. And I'm going to try, like it worked earlier, I'm going to try to share my screen and pull up some of the work that we started doing. We started last year with our chemistry unit, and this year we had to go one-to-one. Oh, we had to, but we went one-to-one this year. And so we kind of just jumped in with both feet, and we don't do Google, we do Microsoft Office 365 or whatever they call it. So all of our stuff is online in these notebooks. And so with like our initial idea, we gave the kids this odor, and we were like, well, what does this look like? How does this odor get from the source to my nose? And we had them smell things and what's going on and what's out there. And so this is, I just picked one student, and this is one of her like initial models for trying to understand what's in this like invisible air that we see. And so even with this, like being as it's all one-to-one, we're still having the kids work together, talk together, so that it's not isolated. It's not like we're in these little, you know, bubbles of isolation. The kids are working in groups and discussing the whole time. So that was one of the things we did. And then we went on, we did some other things, but then we went into this CER. We kind of throw in a lot of CERs where we can, because we're finding that this helps our writing. It supports our ELA teachers. We try to put in math when we can to support our math teachers. And so then we had this CER, and the question was, can something have mass even if I cannot feel it? So then we're going from, can I smell something? Or what are these odors and how are they getting there? Like, oh, wait, it has mass. And we did several different little investigations with that. But then we gave them a short reading, a short graph, and they had to analyze it and give some evidence and write it all up in the CER format. And they really picked up right away on the reasoning section being, oh, that's elaboration, because that came from their ELA teachers. And so like, you know, we're crossing over, and our social studies teacher likes to do CER similar, and she has them highlight the keywords, and we started having them highlight key things for us. And so it's just all kind of, you know, evolved into, you know, science is supporting math and ELA. Social studies is, we're going back and forth giving each other ideas. And earlier I was having a discussion with Janine, and some of our math teachers are even picking up on the CER format for to be able to utilize with the students. So like they're seeing all this stuff over and over and over again, and it's helping them get better and better at it. And it's like all of us teachers are kind of speaking a similar language to the students. So it's really pretty cool. And some other things I wanted to show you here.
Is everybody on the call familiar with the CER?
Yes.
And then claim evidence reasoning? Can't see everybody at one time, so I have to scroll. All right.
Universal thumbs up. So anyway,
one of my favorite baby steps that I like to share and encourage teachers to use as a tool as they move toward implementation.
Oh, and they're so fun. The kids love them too. They really, really, really love to write. So just kidding, but they're getting really good at them. So then we did some other activities, just trying to reinforce the idea that like air takes up space, it, you know, has mass or whatever. And we did some things with like, you know, the cup with air in it, you put the paper towel in it, you put it in the water and it stays dry. And if you put your finger over the wall, you know, put your finger over a straw and put it in the water, you don't get any, you know, it holds in the liquid and whatever. And honestly, I cannot believe how many kids have never done that at a restaurant. They were fascinated by it. This is 6th grade. So this is just an example of them like modeling stuff out, working together. So there's her little drawing of the paper towel staying dry upside down in the water. And then we didn't do our CER for this one. We kind of pulled that one off to the side. So, but starting on this, and let me think here. I don't want to get too far ahead because I have some other stuff on paper that we did. Oh, then we started looking at how solid liquids and gases behave differently. So then we started getting into sort of the heart of the chemistry unit. We started getting into, then we started building molecules. We played with some molecule kits, and we did like hot and cold water investigation. We're like, Crystal, we did this together. And we pulled this in here with the kids. So take a bottle of water, or you take an empty bottle, sorry, and you dip it in a film of soap to like you're going to blow a bubble. And when you put your water bottle in hot water, the bubble rises out. When you put it in cold water, it sinks in, for lack of a better word. And we did that. So that's one of the things that we modeled here on the computers, but then we also had the kids drawing pictures of it, but I'll show you that later when I click off of sharing my screen. It'll just be easier rather than flipping back and forth, because I have a couple other things to show you. But we kind of keep going back to that idea of like, how can I smell things from a distance? Like, look at what's going on here. Like, things are happening that we can't see. We're like this air bubble is moving and we can't see what's making it move. So just kind of reinforcing and building that. And we really got into the periodic table, and not so much to teach them, to memorize elements of the periodic table, but to get them to see patterns. So we were going back to like our cross-cutting concepts, like there are patterns to this periodic table. It fits together for a reason. Everything here belongs here for a reason. Everything here belongs here for a reason. So more so, we obviously didn't make them memorize anything about it, but all of this stuff, from starting with how can I smell things from a distance, got us all into understanding the periodic table. And then we did 2 assessments for this unit. This is one of them. So everything we did, we brought it back to like drawing molecules of a solid, liquid, and gas, and then we asked the kids to describe what happens when thermal energy is added and when thermal energy is removed. We didn't talk a lot about that, like specifically, but we talked thermal energy, we talked how the molecules behave, and so then they kind of had to put it together here. And then we asked them to like describe what's happening in a hot air balloon, and we never talked about hot air balloons. But in our assessment, we took an idea that was similar to what we'd been doing for the entire 4 weeks that we worked on it. And so we just asked them to transfer their knowledge to something else. And they were really pretty good at it. I say they were pretty good at it, but they were scared of it. They were just like, well, I don't know about a hot air balloon. And we said, like, yes, you do. It's not about the hot air balloon. It's about the molecules, and you know about the molecules. And so once they got used to our style of assessments, these have gotten better and better. But they're just so used to, here's your study guide. Here's the 10 questions that are going to be on the test. Here's the test of those same 10 questions, and we expect different things out of them. We usually change up our assessments to, reflect the concept, but not the same exact, questions. We have nothing that's true, false, multiple choice, or fill in the blank. And you can see by all the writing that she does. And then, so we asked what would happen, if we added thermal energy, what's going to happen to this balloon? And they have their key words that they have to use in their explanation. And then we asked the same thing, what would happen if the heat source was removed? So they have to think about it, back in reverse. And then this came from a PhET simulation that we did. This was our CER. We gave them a scenario. How does thermal energy affect volume? We give you 2 examples right in front of you of showing a change in thermal energy, and we gave them a data table, and they had to figure it out. Oh, wait, we heated it up. Oh, look, it's taking up more volume. And so then they pulled data from both of those, put it into their evidence boxes, and they wrote up their little story. And depending on what we're talking about, like in this case, we expected them to tie the CER to another lab or a life experience, like elaborate, connect it out to other things. And so this was her writing for that one. Now, this is a 6th grader's writing. And I don't know, sometimes they blow me away. I wish that they could teach me how to write. Then we did, so I'm going to go back to
here with the highlighting, and it's interesting. Like I really like the way they're articulating.
Well, when our social studies teacher told me this, I was just like, oh, duh. I mean, it gives you keywords to look for. And I tell the kids, please highlight, because you can see if you've used the words, you can see if you have every piece, and I can see it too. You know, so it helps everybody.
Yeah.
So then we went on to our seasons unit, and we directly connected it to our chemistry unit. We started, like, our video phenomena to start it was a Neil deGrasse Tyson video about the universe and how we all came from atoms and we share the same atoms. And the kids were just like, oh my gosh, because now they know what atoms are. And they were just like, how is that possible? And so we did some stuff with outer space, and we looked at planets. And then we really, like, what we really pushed with that unit, though, then tying right in from, you know, our atoms and all this other stuff, is seasons. And we really pushed with them to understand why we have seasons. And that's where, you gotta let go of my arm. Then that's where we've got some of these other lovely little models where we were showing tilt of the earth versus not tilt of the earth. They pulled in some data, and so trying to see if you can see. So here's one, like this example, they showed and wrote up everything with the tilt of the earth on this page, and then they showed how no tilt of the earth affects stuff. And we did, I believe, a PhET simulation with this one as well, so that they could pull some, like, specific data and some measurements. So then they're analyzing data. We're looking at numbers. We're writing about it. Here's this one. And the kids really got into it. They did their reasoning they did their explanations on the back. But, and just, you know, they just kept pushing themselves. And this all stemmed, like, you can even kind of almost tie the seasons one goes really all the way back into the chemistry unit. How can I smell things from a distance? Got us into our molecules, atoms right into space, and how we're all connected. And it's not always perfect. We don't go back to our driving question every day. We don't go back to our phenomena every day that we have class, but it just kind of like hovers out there. Like, this one idea sparks everything and just really opens it up, like, so much bigger. And the kids are loving it. We just started, I'll go back to sharing my screen real quick. We've been lucky enough to be able to use the chicken unit that they're trying to get going as one of the news storylines. And one of the things we loved about that when we saw it was this notice and wonderings page. So, like, our opening phenomena for that is we showed them 3 videos about chickens. One was, there's a debate in Michigan where people want to raise chickens in their town and they're not allowed to yet. Then there's a video of people with backyard chickens, and another video with some people with, like, a chicken farm. So we had them do some noticings and wonderings. And that's one of the things that Erin, I call her my partner, and I really, really liked that we want to pull into how we've written our other units, because we like, instead of thinking about what questions do you have, like, for some reason, they pick up on the word wonder really easily. If I say, you have to write a question, they're like, oh, I don't have any questions. But you ask them what they're wondering about, they totally do. It's so funny, like, how they get hung up on a word. But then the very first thing that this one leads into is, and through the videos, we see some chickens hatch, and then we know that we obviously eat eggs. So kids are aware of what an egg looks like when they crack it. But we asked them to draw us 3 stages of what's going on inside an egg before it hatches, or before it's the egg that you eat. And they're like, I don't know. I'm like, I know you don't know, but what do you think might be happening? You know, it's very few kids have any idea. So it's been pretty funny, like, the things that they come up with. Some of them think that it starts out as a tiny chicken and just gets bigger and bigger. Some kids think it's just kind of blobby in there and moves along and eventually forms. Some kids think that an egg that we eat starts out as a chicken and something happens and disintegrate is their actual word. They're like, something happens and it just disintegrates and then it turns into an egg that we eat, which grosses everybody out when they say that. But multiple kids in multiple classes have thought that. It's just, ugh. But a lot of them think that the yolk starts out smaller and gets larger. And they've had great questions already. They're like, well, what if, and what about, and I think it has to freeze. And what if it does freeze? And what if you do this? And can the chicken have twins? And I mean, it's really been cool, but we're going to get into embryology a lot with this. I don't know. I'm really excited to see where this one takes us, but so far it's been pretty cool. But something as simple as like chickens. Oh, my aunt has chickens. Oh, my neighbor has chickens, but they don't know what it takes to get a chick yet completely, so it's been pretty cool. I'm excited to see where it goes. And just, I think the biggest thing that's been awesome for me is having somebody at work like that. I teach one team of 6th graders, she teaches the other, and we work together on everything. We kind of share a similar vision and are just, I just know that the unit is always stronger because we're bouncing ideas off of each other, and she'll be like, oh, I think this is a good idea. What do you think? Oh, I think this is a good idea. Oh no, let's fix that. Okay. And that is super duper duper helpful. But if you're by yourself, that's fine. You can totally do it on your own. But it is always nice to have somebody to run things by. And I think that's one of the nicest things about like being part of a bigger group like this, having a network, is being able to run these ideas by each other. And so we're currently working, and Jesse's part of it, working with the group, trying to write our own storyline, and it's coming along. I think I'm proud of the work that we've been doing, and it's rolling around pretty quickly. So all of a sudden, so if you have any more questions about that, if you want to email Jesse, I'm sure he can fill you in on all the important information and get you hooked up with our group. So I don't know, did I cover it?
Absolutely. I think you did a great job sharing what's going on in your classroom. One of my big takeaways that I think you were saying, first of all, the student work that you were sharing was 6th graders. Like that was some amazing student work. So I think that supports that idea that the higher our expectations, the higher the work we'll see from our students. And this is something that I just spent all weekend at a math conference and with other state math supervisors. And that's the same thing that we kept hearing there is the higher our expectations are for our students, the higher their performance will be. And we have to maintain these super high expectations. And I think that's one thing that these next generation science standards are encouraging us to do is raise our expectations for writing, for scientific thinking, just across the board. Does anybody else have any questions or aha moments for Rebecca?
I thought it was just cool to hear about how like your use of phenomenon was getting kids to ask questions, and then you were using like all those great questions, and then you were using those questions to guide your investigations. And to hear you say like, I'm not sure where this is gonna go, is really cool, because you're motivating kids through that use of them asking the questions to guide what they're learning.
I had showed Rebecca this earlier when we talked, that this is one of my takeaways from this weekend was Notice and Wonder Woman. Isn't that fun? I'm so excited by that. But we use that in math all the time. What do you notice? What do you wonder? We do that in our math talks. And then to do that as we're introducing a phenomena is perfect. And then I'm hearing of our social science content specialist is using that when she's introducing a QFT in her, which is kind of like a phenomena, in her social science class. So if we can get this across the board, if we can get ELA to do it too, then it'll be great that our students are hearing that language all day long. I think it will really improve their performance. They're going to get it. Anybody else have any questions or noticings for Rebecca?
Anything you notice or wonder?
Well, and I just want to say, like, the girls' work, her notebook that we were going through, she does do a pretty good job, and she's pretty consistent. But it's still, like, that is really indicative of the kind of work the kids are doing. I mean, we find there's about 302 kids that Erin and I have together. And I would say any given assessment, we have less than 10 combined fail.
Wow.
And that's usually a kid that is, like, just not it's just like, you're just like, what are you doing? Like, where were you for the last 4 weeks? It's like a special kind of treat, you're just like, oh, that was a special kind of bad, because we're just, even some of our like kids that kind of struggle in other classes, we tend to like, we see that they do pretty decent with this. And not everybody's as good a writer as that girl was, but like if they're getting their ideas out there and it makes sense, like, that they're learning something. They can't just fake it like A, B, A, C, A, like it's
Right.
like they're pulling in the words, they're using them correctly. And yeah, we're pretty impressed with the, I guess I'd say success rate, how well the kids are doing with their work. So.
Well, I think that shows about the equity that shows how we can get equity in science instruction when you have all these different experiences that the kids are taking part of and the discussions that are happening in the classroom. Kids who, like you said, don't do well in other classes can see success. So that's really nice.
Excellent. All right, so we are going to hear from Nicole Vick now. She is our high school feature teacher. She's a science teacher at Abingdon-Avon School District. So you have the floor now.
Okay, hi. So to kind of piggyback a little bit off of what Crystal was saying, a really good friend of mine is a special ed teacher, and they are compartmentalized. And she recently just left the classroom, but she said after shifting to using phenomena-based instruction and storyline instruction, her special education students were much more successful and required less accommodations than they had previously. So that's like another thing to start to think about, especially when you have that depth of conversation that happens and kids are being exposed to multiple ideas through different ways. So it kind of think about like you have this phenomena that is starting out your unit and it takes multiple puzzle pieces to try and answer. And so they're getting little bits and pieces of it all at the same time. So they're continually building this understanding of something that's sustained. It's not like, I do a chapter a week. They're doing this for sometimes 9 weeks. I've had some storylines that I've piloted, and in 9 weeks, I have not gotten through them yet. So just know it's going to take a little bit longer, but also know that the kids are going to get the skills out of it that they need to be really good problem solvers. So like Becky, I've been doing this for a while. And I was just kind of like looking back at it. I'm like, it's like almost 5 years. It's been about 5 years starting on this journey. Yeah. So it's been a while. I still have classes that I am still teaching pretty much traditionally because it does take a lot of time. I am in a very small school district. I'm one of 2 high school science teachers, and we have 2 middle school teachers. And it's doable by yourself, but it's very hard by yourself. And the more classes you have to prep during the day, the harder it gets. So just know that just do what you can as you can. So even if it's, using a PhET simulation or something and getting them to look at patterns or cause and effect and starting to incorporate some of the cross-cutting concepts, getting them that little bit of exposure is better than no exposure at all. So fortunately, I've had the opportunity to work with some really great groups at the nextgenstorylines.org. And a couple of the storylines that I've gotten a chance to help work on is the Addie storyline. And the anchoring phenomena for this is about a 12-minute video clip from Frontline about this little girl named Addie that gets a scratch playing at the playground. And her mom, who is a nurse, notices that, she's starting to get ill and it's really red. She takes her to the emergency room and they're like, it's not a huge deal. Just send her home. Here's some antibiotics. She continuously gets sicker and sicker. Mom takes her to a children's hospital where she has MRSA. is diagnosed with MRSA. And what starts to happen is it becomes systemic and her lungs start to fail. So then they put her on an ECMO machine and she gets a secondary infection of stenotrophomonas. It's a huge word. And essentially what happens is the stenotrophomonas is even harder to kill. There's like only 4 antibiotics that work on it, and it becomes pan resistant. So the kids are trying to figure out, like, why are these bacterial infections becoming pan resistant? Why aren't antibiotics working like they used to? And so as they go throughout this, they start to discover about evolution. And then it kind of shifts into a second bend, which I've never gotten to in 9 weeks, where they look at juncos in California. And so what happens with the juncos in California is, I think at UC Berkeley, as the campus started to expand, some of the little junco birds stayed and got used to were okay being around humans, and other ones went back up to the mountains. And so eventually what started to happen is they got speciation between the 2 birds. And it was based on behavioral abilities of them to be more comfortable. So the shy birds versus the not shy birds, for bold birds. And so the bold birds were able to stay with the humans and eat their food and start to become separate from their little mountain counterparts that were shy birds and timid, and it gets into cortisol production. So it gets into a behavioral aspect to evolution as well as a genetic aspect to evolution. And so I'll go ahead and see if I can get my thing to go here to share my screen so that you guys can see. So the Addie storyline starts out a little differently, where sometimes you can do a driving question board, but in this case, instead of a model, we actually made a timeline of events of what happened to Addie based on watching the video. So they not only watch the video and take notes, but they also have a transcript of the video, which allows them to dig in a little bit deeper. So I basically become the scribe for the students. So that's why it's all the same handwriting. So we're putting them all on little Post-it notes because they don't always agree as we're going through this timeline. And so the kids are telling me what happened, and then we're just starting to like put them in the order, and where is she starting to get these, the first infection, and then when is the second infection happening, and when is she getting put on the ECMO machine, and and they're left with, she's waiting for a lung transplant. Like, that's the only thing left that can help her. So when you start with phenomena-based instruction, there's a lot of different things you can do. I know a lot of people will start with questions, but you can also start with a timeline. You can make an initial model. So as they go through this process, then we start to come up with some initial questions that they think. So, of course, the big one is, did she survive? Did she get her lung transplant? Is she still alive? And then, how did it happen so quickly? And they think about things every day. Like, if I get a cut, I'm going to put something on it. So why didn't they do that for her? So it's really relatable. And I was teaching this in small class sizes and, like under 15 students, and every single class, somebody knew someone that had MRSA. So it was like either a friend or a relative or a friend of a friend. So it's also something that's tangible to the kids as well, which gets them really, really excited. So another way that you can look at phenomena, so it could be a video, it could be an experience, but you can also look at primary data. So this is another storyline that I've gotten to work on, which is looking at the buffalo population in the Serengeti. And so students first start out looking at this graph. And they start to see like this, that's a huge jump over a relatively short period of time. And so they're being asked to look at patterns at first, and then develop initial models to kind of like explain what they think is happening with this buffalo population. And then finally, we start to develop questions about that model that they make. So what do they think is causing this to happen? And what things do we need to figure out in order to solve this issue? And so it ends up, as they go through this, they go into ecosystems and different effects, and they end up finding that the reason that this buffalo population has jumped up so much is they've eliminated the rinderpest virus, which was a domestic cattle virus that then jumped to the buffalo population and also the wildebeest population. And so by eliminating it in the cattle, it then eliminated it in the buffalo and then also the wildebeest, which is kind of like a good thing to think about now with all the vaccines issues that we talk about. So even though it's something that's far away from us and it's in Africa and the Serengeti, it still comes back to things that students are familiar with. So, and just like real quick, not every phenomenon needs to be phenomenal. So I find them everywhere. Even just driving around, I'll notice like the starlings and little birds, how they fly in the air, and they're kind of like they all move as one group. And it could be something as simple as baking soda and vinegar. You know, kids will notice the sounds and they'll notice the bubbling, but have they ever noticed the temperature changes? So there's a lot of different things, easy things that you can do and find and see that you could use as phenomena that take time to try and figure out and investigate and make sense.
My family makes fun of me because I stop to videotape random things all the time, and it's a phenomena. Anyway, yeah, it makes life interesting. We had a question in the chat, and I believe this is towards Nicole and Rebecca. From Brian. He was asking, is it all based on the questions you ask, or does it come from a unit that comes from a textbook or a backwards design that aligns to the standards? So how do you select your phenomena to begin with? And then what is driving you to move through the content?
Nicole, you want to go first?
Sure. So it depends. So sometimes it comes from the standards that you're trying to address, and you think of what phenomena could help me address these standards. And then sometimes you find a really cool phenomena that you want to see what standards the phenomena works with. So there's really like, I guess, no wrong way to do it, to figure out how you want to pick or choose them. So it just kind of depends on where you're at in your design process.
Yeah, and I would say the same thing. I think like for us, for example, like we have that iQuest unit, like we knew, you know, with this graphic, like we knew what we wanted to hit. We knew we were like headed in these certain directions and some of the certain topics we were going to hit. And I have 150 kids. I probably got maybe 75 different questions. There's just no way we were going to hit them all. It just kind of so happens that like the kids tend to hit on a few that you're totally able, like that kind of weave into what you're doing. And some of them end up being outlandish. Some of them be something like, we cannot possibly do that. Like there's just no way, it's too outrageous. Or we can go Google that. So there's sort of, like Nicole said, there's such a range, but you're never going to hit every question. Sometimes the questions will lead you to something. Now, like with this chicken unit, we're actually going to let the kids try to design something to test out one of their questions. And some of them so far, like more in Erin's class than mine so far, we just haven't quite, again, like Nicole, haven't got there yet. That's going to be tomorrow's lesson. They want to know what happens, like if the chicken's temperature changes or the egg's temperature changes, like will it still hatch? Well, we're going to get an incubator, and we can do some of those things. So like, yeah, we can kind of have that going off to the side while we're continuing to move through some other things, you know. So at the beginning of the unit, I wasn't necessarily going to have eggs in 2 different incubators at 2 different temperatures, but you know, since the kids want to do it and we can do it, we can do that off to the side, you know. So yeah, it just really, it depends. There's no easy answer. You just kind of roll with it. So I'm sorry that wasn't like, I don't know if that's what you wanted to hear, but that's pretty much what it is.
And sometimes you can think you picked a really good anchoring phenomena to anchor a whole unit, and then you really start to get into it and you break it down and you find out that it's not going to get me everything I'm looking for. And sometimes you need to like push it to the side. And it either becomes an investigative phenomenon for a lesson, or it just kind of, you figure out it goes in better in a different grade level. So that's why it's also important to know, to always look, if you're in middle school, you got to look forward and backwards. In high school, I pretty much kind of just have to look backwards. But it's also really important to kind of look at what's coming before you and what's coming after you, so you get an idea of boundaries and limits, and you start to figure out, like, does something fit better at a different grade level?
Yeah, because at the end of the day, you don't have to do it all. You never could. It would almost be impossible. And there's nobody's judging. Like, Crystal's not sitting, there's not a camera in the back of my room and Crystal's watching going, oh my God, she didn't hit that today or something. Like, I can't believe she said that to the kids. So I think that's the biggest thing too, is we are so hard on ourselves. Like, I guarantee all of you guys on this video chat are some kind of perfectionist in some way, and like harder on yourselves than anybody else would be. And don't beat yourself up. Like, it's always going to be better than what it was before. Not to say what we were doing before was awful, but like, we've just found some new ways that really kind of jazz things up, so just kind of roll with it.
Joanna has a question in the chat. She said, is there a site that you recommend that provides examples of phenomena? And she also said dash storylines. So the next gen storylines that I shared is where Nicole's unit about the MRSA came from. So that link is there. You'll have to go to the high school storylines, and then you can find that particular unit. And then there's other storylines on there that you can look at and see how they've used phenomena to drive students. Those are hefty units. So they're not necessarily a place to start, but you're welcome to look there. One of my favorite places to go for looking at ideas for phenomena as they relate to the standards is The Wonder of Science by Paul Anderson. I'm going to put the link in the chat real quick. But Nicole and Rebecca, where else do you find phenomena and examples of how they would align with the standards or meet the content?
Well, like for us, some of it we just had taken what we had with iQuest and kind of ran with it, but then like changed the units as we need to. So it's, and I think there is I don't know if it's an NSTA or a next gen thing, where there's just like this link of all these different like weird like short video clip phenomena things, like and even us using that Neil deGrasse Tyson video or these chicken videos, it's like it doesn't have to be a huge thing. Like my daughter noticed the other day in her cell phone, when she does like with her lips in the right lighting, your lips look like they flap like this. Like even something goofy like that, like a kid could bring that to you, and like you could turn that into something depending on like what if you're doing something with lights or whatever. So it just, there's no real solid great answer. It's everywhere.
I was going to say, for elementary school kids in particular, like their questions and the things they notice, I think make for great phenomena. We have a kindergartner who is bringing forth great phenomenon all the time. So using those questions, I think, is a great resource as well.
I love that.
Yeah, so I put up there, so it's just ngssphenomena.com. I put that link on there, and then the Georgia Science Teachers Association has a really great phenomena website. I also put that up there. And then on NSTA, they have a whole section on NGSS, and it's just ngss.nsta.org. And you can search through standards if you're looking for things for particular performance expectations. There are phenomena listed there now. Some might be videos, some might be data, some might be a reading. And then there are also lessons on there as well that aren't 100% aligned to NGSS, but there's a team of curators, and I'm one of those, full disclosure. And so what we do is we go through and look at those resources and then provide tips for the teachers for alignment. So if you're looking for particular standards that you want to hit, there's a lot of different places to go and look.
That is great. I want to point out, Caitlin put a link in the chat window also for the U of I Phenomena Finder. So that's a great place. I'm going to copy and paste the link to our Science Teachers in Action page too, because we have a list of places to go to find phenomena. All right, any other questions for our presenters? We have 8 minutes for our featured teachers.
I had a question if nobody else does. So I'd just be interested to hear about how you go back to that original phenomenon as you kind of go through the unit. Do you have like a protocol or procedures for that? And when do you go back to it? And how often? Is it something that you're using to assess? That's 5 different questions in one.
So I know with within the Next Gen Storylines group, there's, once you've kind of like gotten to a point where we've figured out some really big thing, we try to go back and revisit and apply that new knowledge. So you could be, once, like for example, with the buffaloes and the Serengeti, once we figured out another piece of our puzzle, we'll go back and update our model. It doesn't necessarily, sometimes you can draw on the model in a different color, sometimes you make a new model. So usually it just kind of comes where you've figured out that piece of a puzzle, to go back to it incrementally. And I know there have been places where I've used like other units and lessons from other places that I kind of think to myself, like, we figured out some really important stuff right now, and we need to take stock of that, and we need to relate it back to our very first thing that we were trying to solve, and try and figure out how, or try to put how that helps us figure out a piece of that larger anchoring phenomena. And I use the word figure out a lot. But that's what they should be doing, right? They should be figuring out a lot.
Figure it out.
Yeah.
I wanted to share our Science Teachers in Action page really quickly. Oh, I have stuff all over the place. Here we go. Can you guys see my screen? All right, so this is our Science Teachers in Action page, and then I clicked on resources and went to classroom materials. So on this classroom materials page, which our site is in, it'll be under a little bit of construction, so things might move around a little bit, but we will still keep all of these resources here for you. I wanted to point out this IMSA model and GSS lessons for kindergarten through 3rd grade, if we have any elementary teachers here. But it's a K3 NGSS aligned lessons, and they did a good job of having phenomena and then having the experiences there to help the students figure out what was going on in the phenomena that they observed. So that's another one besides the Next Generation Storylines to check out. And then also there was the Inquiry Project has, I know I have some 3-5 teachers on the call. So they have an example for student-driven inquiry for understanding matter in grades 3 through 5. So that would be worth checking out as well. So that link to this page is in the chat window for you. All right. Do we have any last questions? Okay, I am going to share a link to the post survey again in the chat. If you would please, it's just a few reflection questions that help us measure our impact. So if you would please do that, and it will also guide our future IL SciComm so that we can make sure that we're meeting your needs. There's a question in there asking for suggestions for future IL SciComm events. So anything that you guys want to learn more about, we would be happy to host discussions around. Or we can try and find guest speakers like we have in the past. And I just want to thank everyone for attending. And thank you so much to our 2 feature teachers for putting yourselves out there and sharing your examples with us.
No problem. And I just put a link to our little middle school storylining group that Jesse's a part of too, so that, you know, people can kind of follow us on Facebook. We're not that exciting on Facebook, but, you know, we're more exciting in person. But if anybody wants to, you know, be part of that group, just reach out and we'd be happy to have more the merrier for sure. So
that's great.